Hello and welcome to Between Two Servers. Today we're talking with the engineering team on multiplayer Knockout City at Velan Studios. Welcome to the show, everybody.
Thanks, Glenn.
All right, so we got Chris McAvoy, Joe Morton, Corey McWilliams, Chuck Homick, and Jacob Langworthy. And if I screwed your name up, let me know. All right, let's cut to a quick clip showing all the cool gameplay in Knockout City. Super unique game. Dodgeball, online dodgeball, catching, throwing, parry. There's a lot more here. It's not just your typical FPS. Take a look.
Welcome to Knockout City. This is your humble DJ, and I'm beaming a very special upgrade down to all you brawlers out there. Knockout City is free to play. City is a futuristic city of tomorrow, a city where you can hang with your friends, just as easy as you can juggle. And Knockout City wouldn't be complete without a brand new technological toy to play with, Boomerang Ball. And that isn't the only super science surprise we've got up our sleeve. So grab your crew, grab a ball, and hit the streets. Because we're free to play forever, baby. The city of tomorrow is here, and the brawl has just begun.
Okay, we're back with the engineering team. You've recently, almost a year ago, launched Knockout City. It was the second game from the studio. Over a year now. So, and you'd been working on that for how many years before launch, Chris?
We started in 2017.
Okay.
So a while.
And what's amazing is that although you prototype with, you actually shipped the game with a custom engine called Viper. Chris, can you tell us a bit about the decision behind that? Why you guys went for a custom engine for your multiplayer game in 2021?
That's a good question. I think so. Throwing the ball, catching the ball, interacting with a high-speed moving physics object was sort of core to our gameplay. And yeah, I mean, we thought a lot about ways to reduce latency and improve responsiveness. And I think where we landed was we need to do a lot of client-side prediction, and basically the entire world. And yeah, I mean, once you start doing that, you're talking about sort of radical changes to how the simulation works, maybe in Unreal or whatever engine you're using.
So we're not really even talking FPS network at this netcode style at this point anyway. It's totally something different.
Yeah, I mean, it was really, we knew we were going to be playing over the network. We knew the server needed to be authoritative. So we knew those things. So that led us to client-side prediction. And then from there, it was just, well, are we going to massively overhaul Unreal or something like that? Or should we do it ourselves? And many of us had come from a place where we did it ourselves already. So that seemed easier at the time. Maybe it was unclear.
So there's something really important for everyone watching this is like, this is not your first rodeo. No one on this. I mean, all of you have shared experience at Vicarious Visions, and at the new Velan Studios. This is the first original IP by you guys, which also worked on the cool Mario Kart home circuit game, which was that AR one. Super cool, very refreshing. Did anyone on the call work on the Mario Kart one?
Yeah, a few little bits. Yeah, I remember.
It's super interesting.
I don't know if it was 2018 or 2017, getting a little Raspberry Pi and
you stuck the Raspberry Pi in the car?
Just trying to get UDP packets to go back and forth between the car, this little Raspberry Pi, and the PC, so that we could have a development environment
that's super
made
awesome.
sense.
So for everyone on the call, let's do like a quick show you what the Mario Kart home circuit looks like as well.
The world of Mario Kart is racing into yours. You can bring the action to life by setting the course in the real world. Mario Kart Live Home Circuit, rated E for everyone, only on Nintendo Switch. Cool.
So let's dive into this a bit. So what were the challenges getting data from the car to the Nintendo Switch, and how did you folks attack that? A networking problem, but not a traditional one.
I guess there's a couple of very interesting things with the Switch and how that whole thing worked out. The fact that everything has to be low latency, right? So it's UDP. But the Nintendo Switch is even more unique than that, insofar as when you're playing the game, the Nintendo Switch doesn't have an internet connection to the outside world, so it actually acts as an access point.
So it's actually like a Wi-Fi router to the car.
Yep, exactly.
That's awesome.
So that was a very unique aspect to working on that.
Very cool. And you're actually streaming videos, so not only do you have latency, but actually also a bandwidth problem too, I would imagine.
Yep.
Cool.
Yep.
Did you guys do any custom encoding or any tricks that you had to hit up for that?
There were
Anything you can talk about? You might not be able to talk
tricks.
about
I
it.
don't know what we could talk about, but there were definitely tricks. You want
There's magic sauce here.
do
Okay.
some things, yeah.
Pretty cool. So back to Knockout City. So you recently launched it. You worked on it for a very long time. So 2017 through to launch middle 2021.
May or end of May 2021.
That's a lot of development. But as you know, all the hard stuff happens after you launch the game. What was the launch like for all of you guys?
I'm trying to think about what I can remember. I remember.
What can you remember through tears?
I remember a lot of early mornings.
So much work.
Definitely a lot of early mornings. We had there was the actual launch, right, where it's a cross-play game, cross-platform, and so when you finally get into retail on all of the consoles and you find out the little things that were supposed to be the same as development, but actually were not the same. And so there was definitely a bug on, I think, Xbox, where the game just didn't boot up. And that was one of the early things. And shifting more towards like the back end and actual like internet related things. I remember obviously we were iterating rapidly on our first sort of back end that we had written and deployed to production, and we had a bug in our zero downtime deployment. So I remember some of the early mornings were due to the fact that we wanted to wake up and do a deployment.
So you had to look at that like daily player curve and then do your deploys at that's so painful.
Yep.
I'm so sorry.
We were up at
I've been there.
I've
been there. It's really horrible. And then you do a deployment and you're like, you mess something up and you're like, and then you have to have downtime. So you didn't quite have the like seamless uptime.
Oh, no.
Yeah.
Actually, I mean, other than those really early morning deployments, I don't know if we really had any downtime.
Right. It was pretty much, we knew that
more like risk management.
Exactly. Like, so we knew that when we had to do one of those deploys that backends would not exit gracefully. And so we would basically try to fix it, and then it wouldn't quite work out. And we're like, okay, well, I guess we can have another stab at it and we'll try again tomorrow at 5 a.m.
Got it.
After enough 5 a.m. mornings, we were like, okay, we can feel comfortable about doing this during the day now and not disrupting everybody.
That's pretty cool. So we got two really big topics already. I think the actual game netcode itself and your custom engine and all the stuff you did to do that, but also the back end services and the matchmaking and all the things around the launch of your game. Let's hit up the unique engine first and the netcode approach. Who wants to talk about it? Chris, are you the guy?
I think I'm gonna.
Chris is
I guess I'll start.
It's Chris.
Sure.
So you got Viper. You've got a totally custom engine. What's unique about it? What's different about it from other engines?
Well, I mean, so going in, we want to do a lot of client-side prediction. So the notion of rolling forward and rolling back, if you're familiar with those concepts from like GDC talks or something. That's something that our engine just does. Like you have to turn it off.
Right.
So it's a thing that's just sort of on by default. We try to be deterministic in our simulation. And that's another thing that's just sort of like determinism checks and that kind of thing are
Is
on by
it
default.
hard determinism, like you're literally
No.
checksum in game state?
Well, I mean, we are literally checksum in game state, but not all of it.
Okay.
And what we're really trying to do is get a deterministic simulation just for like the core parts of our gameplay. You know, you enter the UI or something like that, all bets are off.
So there's a do you have a boundary in your code, like a deterministic core, or is it fuzzy wuzzy?
It's fuzzy. You can sort of opt in and out of determinism checks, and sometimes people don't opt in and out correctly. And so it's an ongoing thing, but no, I mean, to this day, we can run like the core of our game and know that it's at least deterministic on that machine.
Okay, got it.
You know, it gives us a sense that like our prediction on the client is probably decent. Maybe not.
So
perfect.
one other thing that's really interesting is vscript, and specifically from an article that you wrote, which we'll put a link up here, going on about vscript. I mean, you've got a core in C, not C++. Big discussion there. I fully agree with you. But vscript, you can run it in a VM, but also compile it to C, and it's very interesting because what do we got here? An iteration time thing.
Well, yeah, but not only that, but and Joe was actually the person that wrote our first version of the vscript compiler, so I'll commit to him. But so Joe talked about how Xbox didn't boot at launch in production. And so what we were able to do is scramble within like a half an hour and use our untested content,
so powerful though.
Right, untested content deploy to push a new vscript to Xbox to unblock ourselves from the crash and get us into launch. Like we turned off like one of the like checks was failing, and so we're for like some upsell screen or something like that, whatever. So we turned that off at launch using vscript running in VM.
So you can actually have a whole load of code shipped, but then override with vscript large parts of it at will. Yeah.
And Corey wrote all of that content update stuff, which was awesome and amazing. But pretty much any data.
Very cool. So interesting thing. So let's dive into how we network the game. So I'm going to take a rough guess. Designers work in vscript, and you've designed vscript so that it is the thing networked.
Yes.
So you're not going in there like sweeping up little. I always think of it like a little pooper scooper. Like you don't want to be the net coder, go on behind the game coder and the designer scooping up the poop and like you're networking it, right? It's like no, you create a structure that's networked, and then you make the game with that structure. So tell me, how did you create a structure with vscript that helps you network your game?
I guess the precursor there is that we did the pooper scooper thing on a prior game, and so
oh my god, it's hell.
What led us to
yeah.
How did we do that? Well, I mean, you know, there's a few things. One, you know, we sort of split our sort of what we call constant data from our mutable data associated with vscript, and then, you know, with one switch you can make a whole script or all instances of that script be replicated over the network. And so in that way, it's pretty simple. And then on top of that, whenever you run our game in development, you have to boot up a local server and a client. Like there's no way you can't play in a non-networked way. They're
in the same process. So there's no context where it's just like, well, this is just a single player game. It's, no. This is a client and a server in one instance.
It's in one instance, and there's actual, like, we start up some sockets and we connect them together, and we actually encrypt this stuff, and like the whole pretty much stack is running. So you can't sort of sidestep it.
So we did this on Titanfall 1, Titanfall 2 as well, a local server, client and server running in the same thing. Even to shipping, the single player game of Titanfall 1 and Titanfall 2 is a client and server running in the same executable. Folks, the right way to do it, there is no single player, even if there is single player.
Right. Yeah, no, I think that's totally how you got to do it if you're going to make like a real serious competitive
The
game.
backend is in there too. All of our local builds also have the backend. If somebody connects to your local build, they can join your group or start matchmaking or whatever they want.
That's amazing. So So again, like in Network Next, Chuck, we love Golang, right? Golang's awesome. Really, but it's not C, and it's definitely not going to be running inside Visual Studio with an F5. And you end up with a schism between back-end programmers and game programmers, totally different programming knowledge set to code in this back-end language versus C. Now you've got the back-end written in C, running in the same process. Do you even use vscript in the back-end?
No,
we haven't gone that far yet. I think every few months somebody is like, is this the time where we're going to add the vscript interpreter to the backend?
It just feels like it's like that extension, but again, I don't know if it's really valuable. So writing a backend in C in 2021, is it fast, or does it take a longer time than say in Golang or Python or whatever?
The process of writing it, I think once we got all the core parts we needed to do it, it was fast.
It really is that you're building your own ecosystem to write your own backend, and then I guess you've got to build the tooling, and then past that point, you're okay. So let's talk about the benefits, Corey. So you've got the decision to write the backend in C, somewhat controversial in 2021 from a traditional backend point of view, but justified given the benefits that you're all seeing as a team. Let's talk about that. What are the benefits that you get from your backend in C versus a different language in your backend versus in your game?
I mean, like we said, being able to push F5 and set breakpoints and everything and step through it all at once is powerful. Being able
I love
to
the idea of your backend just being in there every time you run the game is pretty radical.
It's like any artist who boots up the game will see like the same experiences in production. I would say like using game data types just naturally get them in the backend.
So you avoid a lot of that marshalling back and forth, and okay. So that's it. So you've got an ABI effectively now that goes across your client and your server and your backend potentially. I might be making it sound more awesome than it is, but
yeah, maybe a little bit there. But
yeah,
cool.
I mean, the cool thing is like I think when we started writing the backend, we kind of thought like, oh, this is a generic thing, it's a backend. And then as reality hits you over the face, you're like, no, it's not really. It's Nugget City's backend. And so eventually more and more game data ends up there because that's the most useful place for certain things to go. And like Corey said, you could just load the data. We're like, okay, well now we'll deploy this chunk of the data tree with the backend, and then we can load it up and we can look at it and we can use the same code to interpret it, which is pretty cool. And it's kind of like the benefit of C, or the fact that it's all in one code base. So a programmer, like we try really hard to not have barriers. So if a programmer is like, oh, I'm going to work on this new achievement system, or like contracts, for example, in Knockout City,
you're going to go top to bottom, aren't you? You're going to go all the way through the game code up to the back end and back down.
Exactly.
There's the benefit.
And into the editor as well. So they can, if they're like, oh, hey, I want to know about this contract on the back end, or when the season ends or something, if they know how to do that in game code, then they automatically know how to do it in the back end. They might just have to ask a question like, oh, hang on a second, like when is this data loaded? And they have to figure out how to load the data on the back end. But once you do that, you're over the hump. And same deal, like if you're in the editor and you want to do something special with contract data, you know how to deal with it because it's all the same code base.
So how does the editor fit in? Is the editor part of it's obviously all part of the whole package, or is the game running in the editor, or is the editor the game? Who's most experienced with the editor side on the call?
Components we have inside the Viper process are the game, the backend, the editor, the data D, which is how we build data. I think those are all the main ones. There might be some other.
Do you have one process loading DLLs as modules, or how does it all?
No, but this is one project, one process, and it can fire up all those things, multiple instances of some of those.
Okay, so you've actually designed all of them to have their own instance space, so they're not. So obviously, the client and the server are not directly talking to each other. Maybe we could talk a bit about that, because you see, in engines I've worked on, you often come to the party where they haven't quite thought of that from day one. And the only way you can get the memory separation, because the game code's full of statics, is you're going to have a DLL for the server and a DLL for the client.
Yeah, so we have a big rule about no singletons, no statics, and I mean, we started from 0, and so that's where we are. It's quite nice.
Cool.
And so, did you want to talk about the app architecture, Chris?
Sure, I can talk about that. I mean, we have a little frame around each of these things, like the back end is an app, and however many clients you're running our apps, and the server's an app, and all these things are these little apps. And so it's kind of like, you could imagine it's like a thread local concept almost. An app is a bunch of different, it's a collection of threads, but they all have thread locals that point to your current app. So you can be in any sort of Viper thread and you can be like, what's my app? And then you get your app, and then you get a bunch of services off it. You're like, give me the file system, give me the memory system, give me the entity system or something.
Got it. You've created your own operating system in C for games.
I know. I mean, yeah, a little bit kind of like that. Sure.
Yeah. So Jacob, calling on you. What are some of the cool challenges that you've done around the multiplayer in Knockout City, leading up to launch or post-launch?
So Chris kind of mentioned that we do a lot of client prediction, and part of that is like a temporal, what's it called, temporal displacement or whatever, where the client is actually running ahead of the server, and it will speed up and slow down based on how like latency and packet loss and stuff like that. And so I think kind of getting used to that system and understanding types of problems you have with gameplay.
It's a bit of a mind fuck, really, isn't it?
Yeah, a little bit. And like, it's a very interesting thing to just kind of know that the client, everything you're seeing is kind of a prediction. And the problems you run into are like with like mispredictions and things like that. The way we solve them, I don't know, I feel like we all have, it's this thing where if there's a problem with a misprediction, that we all kind of have, like, there's 5 of us, so we have 5 different ways to solve it. And it's just, I don't know, interesting. For me, I'm like, let's do things like forward client input from the server to all the clients, so that we have
better extrapolation.
And so like we may not have perfect prediction for all clients, but we have like enough where most people have like a little information on what all the other clients are doing before the server corrects anything. And so I think that kind of, I'm not sure if we ever figured out if that helped us or hurt us, but
it's certainly somewhat of an uncharted territory. I mean, I'm getting a big kind of GGPO kind of vibe. There's definitely more of a, so I mean, really, you've kind of given away, like, you're running more simulation on the clients for the other objects. This isn't an FPS model where although the server is authoritative, it's a dedicated server architecture. We're talking about something where it's not that like Call of Duty or Titanfall or whatever, where the real objects are on the server and the players just have their one object and they're shooting at interpolated ghosts of other people, and then we're all working it out on the server with lag comp. It's not what's going on. Like, you're throwing a ball, you're catching a ball, you're dodging. It's a lot more like a fighting game in its netcode, because it's about interactions between 2 players, and some of these interactions cannot fully be predicted. I can't predict if someone's going to dodge or not.
Yeah, and so we don't have a lot of like instantaneous actions, which kind of helps, I think. And so like there are things. It's a little bit more like a fighting game where we draw on things like we have a tackle in our game, and that has, I'm not going to remember the fighting game terminology here, but that has like the warm up phase, and then you like actually start entering into the animation, and then you do the tackle, right? And so it's this built in. I'm
going to guess that the correct terminology is whiff, because I remember it from God of War, because those guys were so into combat. But yeah, I could be totally wrong. So you got that warm up, and you're trying to hide some latency in that. And what are you doing at that? Are you kind of like trying to get the server to kind of confirm that you get it, and you're hiding it with anim, or how does that all go?
We don't actually, I can't remember if we have like a few things where we ended up trying to do some confirmation, but in the end, I think we kind of, like, my personal preference is that we don't, that we correct instead of confirm. But there are certain things, like maybe the hit sound effect doesn't play until the server confirms it, stuff like that. So like maybe pieces of it might be.
You can tease apart parts of the hit and the hit reaction, and have some be predicted and some be confirmed from the server. Very cool. What else can we talk about for the netcode? Are there any other like crazy things that you've seen when you launched that you didn't expect? I mean, how did you test prior to launch latency, and how did the internet surprise you?
I think we did 2 betas.
Did 2 betas, and we did a closed alpha. I think that gave us a lot of insight. Corey was in charge of our stress test, load test situation, and we load tested the dickens out of the back end. I think that helped us a lot, although there's a couple things we missed, because I remember after launch being like, oh, there's a message we never load tested, and it seems to be slow. Yeah, I don't know if we were surprised by the moment to moment, honestly. I think we did a lot of like,
I mean, the launch went quite smooth, and I mean externally, of course, there's always like,
yeah, I mean, like I think we had been running with the model so long, and in a development environment, we always play with like fake lag and fake loss and all this stuff, that it was pretty solid. Really, I think for our moment to moment, the name of the game was, could we get our performance good enough so that when we needed to roll forward so many times, we could do so in the 60th of a second.
So you've got this model where you are, as the client, your player is ahead in time, which means when the server correction comes back for the whole world state, including you've got to kind of bring that sim forward by, I mean, you're 60 FPS internally, or is that render? Help me understand the tick rate. What's the parameters here?
It varies a little bit.
Okay.
But yeah, I mean, we have a lot of roll forwards to do.
And CPU bound.
Right, we're CPU bound. I mean, we do a bunch of tricks, and you and I have talked about this, Glenn, where we'll induce latency on the client side if the latency between client and server is so bad that we can't roll forward enough to cover the gap. And then we do this other thing where we might actually sim only every other frame if things get really, really bad.
So you've got kind of like a shit's hit the fan mode, drop the sim rate, try to recover so you don't get the
and then add client latency. And there's all these tricks we keep piling on. So like, I mean, there's a core sim rate, but like there's a lot of stuff that piles on. So it's hard for me to say really, it's pretty connection dependent on what you experience moment to moment.
Yeah, makes perfect sense. So effectively, CPU bound on the rollbacks, a lot of tricks to kind of avoid the spiral of death of not being able to resimulate fast enough so that in real time you can step forward in time. The game gets further and further behind, and then it's over. And of course, you guys also have late join, right? Do you let people hop in mid game, and obviously you're not fully deterministic because they're able to come in and get state and join in the game?
Yeah. So I mean, our
That's a big
model
deal.
is one of the server is replicating the entire world to the client. We don't have like a full world snapshot necessarily in a packet. We sort of prioritize all the game objects, and we take the top N and we fill a packet kind of thing.
A washing machine model.
Right. Interestingly, we don't fragment ever. We fill an MTU and then we're done.
Yep.
Because I don't know.
The next packet's going to get the
next packet's going to come along,
and
we never bothered to fragment, which gives us a pretty low bandwidth, which is nice.
It is a really, really nice. One of the really nice things about the sort of washing machine priority accumulator packet model, of course, is that you can just literally say, I'm going to hit this packet size and I'm going to fill it. And then if I don't fill it, then I'm going to put them in the next one. Now, the challenge, of course, is that you're not necessarily getting state updates for every object in the world. So the consistency trade-off is there, but different strokes.
Yeah. So we've added like a dependency system where you can say, hey, I have a bit of data that points to some other object. So
these two things always need to be together.
Right, and there's an ordering thing. Like if I depend on a thing, it needs to come first before I get it. So
do you guys do relevancy? I mean, your worlds are relatively small, so I would assume that it's most of the objects are active, or is it a distance-based frequency? How does that work? Getting really into the nuts and bolts here.
There's an interest function that's based on distance and also based on type of object. I think if you're a player or you're a ball, you get a priority boost.
Of course.
I don't know. Jacob might remember some other things, but I know we played with that.
Yeah.
No, I think that's mostly it. And it like cascades through. So like if a player depended on something, that would
I
have
see.
the player
You do the kind of like the recursive walk, and that bumps up the priority. That's very cool. Okay, so let's talk about the server. So we've got the server running simulation. The server is, I'll take a rough guess. It really is just stepping forward at ticks, and if it has input, it's going to apply it. It's going to try to get input from all of the players. And in this model, it really is the client's responsibility to deliver input before it's simulated. Is that, and that's your time synchronization.
Yep.
Got it. So if you don't get any input from the client for that frame, do you just go, wow, too bad, dude? Or do you hold the same input, or how does that all work?
I think we hold the same input, but not entirely. Like if we see a button release, we'll obviously complete the release, and we won't copy that forward to the next frame, and we'll do some other things.
Yeah,
I know Jacob is trying to think about this. I don't exactly remember. I remember working on this though with Jacob.
I know we used to walk people off cliffs, and then we stopped doing that.
Yeah. You can't extrapolate too far. Yeah.
We might just cut it off.
We might cut it off. Yeah, there's a bunch of code in there to do.
I think I did something on a peer-to-peer game similar. It's like, like someone lag switches and then they run in the wall, or they disconnect and they run in the wall, or they run off the cliff. It's kind of annoying. So I think, again, it's different in the client-server context, but in the peer-to-peer context where I did it, which was God of War, was it's like, I haven't received a packet from that client for 0.25 seconds or longer. Stop walking. It's okay. Something like that.
I think there's something like that, but some context there.
Cool. So at a very high level, how do you ensure that the client delivers the input in time to be simulated on the server? And then at the same time, how do you there's competing things here, right? You absolutely want to deliver that input before the sim step on the server, ideally, right? It would be bad, but like, it's not the end of the world, but it would be bad. But then at the same time, you've got a competing priority, which is, I don't want this really long sim delay. I call this the window of bullshit. It's like all the bad stuff happens in here when the client if the client can be ahead by 5 frames instead of 30, well, firstly, it's lower simulation, but it's also a smaller window of bullshit. And that's the window where you get shot behind cover, where you think you killed someone, but you don't get it. So there's no correct answer here. This is like almost the scariest part of any network code base. It's kind of like, I think it works, but I'm not really sure.
I mean, we have some feedback loops, right?
Yeah.
So, I mean,
it's like a PID controller kind of almost.
Right. Yeah. I mean, we're looking at ping, we're looking at packet loss, we're looking at jitter, especially, and that'll really cause us to maybe add some delay as we see more jitter.
So you want to be kind of safe.
Right. And we have this historical buffer as well. So we're looking over the past like 30 seconds or something and trying to make the smallest amount of latency that is still safe.
Yes.
And then when we send input to the server, we send all of the input that hasn't yet been acknowledged.
Okay. So you keep your packet loss with that. So that's a good strategy.
Right. And then I don't know. I mean, there's a lot of like sort of magical numbers a little bit and tweaking it. Like I built like, at one point I built like a sort of an analytic state machine of the model so that I could play with all kinds of jitter and packet loss and then look at the parameters of our feedback. Look at the reaction or our feedback loop, just sort of like in an analytic kind of Excel kind of way. Like, how does this behave for all possible values? And we picked some that seemed reasonable.
That's pretty cool. So there's another approach that I don't know if it helps your game at all, but something for the viewers is like, I've done the exact same thing that Knockout City has done, especially in the realms of physics simulation, because of course you can predict the physics simulation to a point, but if it's a bunch of rigid bodies and the different players are affecting the same stack of bodies, like you really just have to run the simulation itself to extrapolate. So I'm in the same situation as you folks, where the server's running the simulation, doing a traditional step forward, and the client is trying to keep ahead of the server, predict ahead with these very CPU intensive steps, right? Maybe even more CPU intensive when it's like Havoc or, like a physics engine with rigid bodies. And then you've got this kind of really complicated, like, but not too far ahead, and like, oh no, now I'm CPU bound. So it's quite terrifying. There's a different approach that in FPS games I've seen that kind of blew my mind. So here's what I've seen. Again, it wouldn't work necessarily for this, but I've seen a different approach where you split the world up into each player, and each player have their own time stream on the server. And the players only actually move forward when they get an input. And it's actually, the inputs from the clients are less about inputs for this time. It's more like, here's my DT plus my input for this DT step. So each client is kind of moving forward in a DT. And they don't even have to be fixed frame now, right? And then the world itself kind of has a traditional stepping forward, but the clients are like a little bit ahead on the server, a little bit behind. And where this all kind of comes out is that there's this crazy lag comp code looking like, when you're shooting someone in FPS, you're not looking at their position right now. You're basically reconstructing, when I shot on my client, what on the server in the ring buffer of their bone positions and orientation, where were they? And then the code just moves them to that, and then it resolves whatever the hit is. So it's like, that's how we get that kind of, the clients being in different time streams, but that relieves that whole kind of like terrifying, like, I got to deliver the input in time. But yeah, so alternative approach. But again, when it's so much about simulation and player-to-player interactions, how much are they really decoupled in a game like yours? It really seems much more like a GGPO style kind of fighting game simulation than an FPS.
Yeah, and definitely I think that's where we came from. I don't know, I've had some similar thoughts, Glenn, at various points. And I think
you just got to pick. You
just sort of got to pick. And
yeah.
When we were starting the game early on, one of our main designers was very inspired by fighting games.
Yeah,
and he's like, "This is a mix of fighting games and an FPS and this other thing." And I'm like, "Okay, well, I'm gonna sort of like anchor some of the network architecture around that concept."
Yeah.
How it turned out in the end, I still think it does have attributes of a fighting game. Whether or not we could get away with like a different architecture at this point, maybe.
It'd be such a radical change.
It would be. Also, I mean, we probably couldn't do it given everyone is used to how it plays now. But you learn so much, and after 5 years, it's like, wow, maybe we should. There really
is no right way to do it. There really is, for this game. There's the Knockout City flavor. Right. And I guarantee you, if you change the networking approach or the flavor of how latency is hidden in your game, your players would notice. It's like Halo is Halo because of the way that it does it, which is different to Quake. Unreal Tournament, I think, doesn't have the right netcode like Quake, but so does Battlefront and Halo. And if you tell someone with Halo that you're going to change how Halo is networked to be more like Quake, they'll murder you. It's just like, that's the feel that they want. So it's complicated. All right, let's talk about matchmaking. Who's the matchmaking person on the call? Or probably
I'm the matchmaker.
So like, massive challenge. You've got people playing the game, and the classic matchmaking question is, it's 2 a.m. in Australia. What do you do?
We do our best.
Correct answer.
So I worked on that quite a bit with our lead designer. And
what were your goals? Like, what was the, like, we want the player to have this experience? Like, what was the guiding principle?
Well, we know that there's this triangular trade-off.
Right.
We want the players to have the lowest latency, the best match with players that have compatible skill, and we want to do it as quickly as possible.
Yeah.
And it's not
pick any
like
two.
It's not like I was going to say. It's not quite like pick any two, because sometimes you just get one.
Sometimes you get all three.
Or if you turn the knob too far on one, you lose the other two, or something like that. And so we started out by generating a lot of fictional scenarios. I would use a random number generator to say, like, okay, these are my players in my world, and there's 16 of them, and I have to put them in 4 different games of 4. And then I try to do it by hand, and then I try to see if there's an algorithm that would produce the same output. And if
what's
it didn't,
the pattern?
And then there was like, okay, well, how do we do this over time now? Because you have people coming and going from the queue. So
do you guys break up? Do you break up at the end of the match and throw back in the match here?
Yeah, of course.
Cool.
They, I mean, if they want to.
Yeah.
At the end of the match, you get the match summary, and you can re-trigger into matchmaking immediately. You can watch all the cool things that you've won. Or return to the game mode or something.
I mention it only because I've seen a trap. Some games, like I've worked on some where we try to keep the same group playing match after match, and what you create are these little isolated islands, and people try to join, and then there's no game with needs one person.
Sometimes it happens just as a side effect of, like, everybody gets dumped into the pool at the same time, especially in League. Depending on the number of players, I can jump into a League game and I'm a certain level, and there may be like 10 or 15 people in the world at that level at that moment. So I'll finish a League game. Usually I get crushed. And then I'll re-trigger for another matchmake, and I'm like, oh, it's the same guy again. I'm just going to get crushed again. It's fantastic.
Which brings us to an interesting exploit, which is boosting. How do you combat boosting with your game?
We have a really good set of community managers, and they have their finger on the pulse of the community, and they know, like, who's doing what, and people reach out to them and say, like, hey, this player, I know this player, I know their level of skill, this rank is not attainable by that person. And we have telemetry, and our on our team can go into the logs and say, like, oh, okay, yeah, it looks like they've played 50 games in a row where they've won 10-0. It hasn't really been a big problem, just because the competitive community is a very
very tight knit.
They're a tight knit community. They're on the Discord. They're all on, I guess they're on Reddit too, and they all chat with each other, and they all know who each other are, and sometimes they meet in real life and have drinks and stuff. So that part of that is really neat. So that hasn't been a big problem.
And so I would assume the same, like cheating in other forms. Are there any exploits aside from boosting, like that you've noticed that's specific to your type of game? I mean, it's less that like wall hacking or aimbots would really be a thing here.
We have exploits. So if somebody finds out you can roll into a ball and pass through this corner in the geometry, then you can make 1 point against your opponent, and then have your whole team roll behind the wall where they can't touch you. Or those are bugs that people post video, and then we fix it, and then it's over. There was a legend, I guess, of some kind of auto catch script that was claiming to say, like, oh, we'll scan the screen, and we give you a visual warning that somebody's throwing a ball at you, and so somebody's like, install this program and it'll screen scrape the warning indicator and then automatically catch the ball at the right time. It was fake. It was a crypto miner.
That's kind of funny.
So as far as I know, and you guys can correct me if I'm wrong, as far as I know, there's no like client side exploit of that nature. Not anything that's been like proven.
Yeah,
we've had a couple of like players get more XP than they should, or something like that. Or
again, if they find a bug, if they know that, like, oh, if you do this thing and then crash the client, then you can do the thing again and you can get the thing again.
So it's sort of like metagame and XP progression exploits. It's not too bad.
And I don't know why people do that, because it's not a big win. It's the same thing about people boosting in league play. You have a player who's like, Diamond 5,000, and everybody knows who you are, and they're like, we know that you can't do this. So
you're not impressing anybody here.
I told our community managers, like, why don't we just have a live tournament with all the top players, and then we can stream. Yeah, we could stream the games with these top players and see see who shows up. I mean, I guess the the booster's not going to make it, or at least they could show up and be really embarrassed, or they try to give their controller to somebody who can make them look good.
It's really cool. So what's an interesting thing to talk about? I think one thing is the number of platforms that you're all on. Cross-play. I mean, it's an essential part of your game's success. You want to bring all of those players on different platforms together.
I certainly thought that was nuts. And I'm the latest one to join the team. I joined in the, you might know this date, March of 2020. Which is also interesting for another reason. But
sounds like something was locked down.
It was one of the many decisions that I walked into a brand new company and I said, "You're doing what?" Like, in addition to like we're doing everything in C, and we wrote our own engine, and we're on every platform imaginable. And I'm like, boy, you're really not making things easy for yourself, are you? You're taking every aspect of this and you're doing it in the most difficult way possible. And
but I tell you, like, being a multiplayer game, 2021, 2022, you just can't fragment across platforms. You just can't succeed without crossplay these days. So I mean, put that onto the pile of massive mountains of work that need to be done just to launch a competitive game in the market these days, a multiplayer game. It's the amount of cross-play work required. So maybe we could talk about this. What sort of work did you have to do to make parties, invites, cosmetics? I mean, this is an obscene amount of work. And again, you did it all. You didn't use really any middleware at all.
No.
You're looking sad there. You're like, I wish I used some middleware.
No, we didn't. No, it's remarkable. I do remember being in the meeting. It's like, well, we could build all this, and then we did it.
It's cool.
Yeah, I mean, it just seemed like we had to do it. I mean, I think we really try to make all our big choices based on like, what does the game really, really, really need? And we knew, you were right, Glenn. We really, really need to be crossplay. To make a new IP work.
That's true.
So then it was. At that point, it was just sort of clear. It was like, oh, well, I guess we have to do it. So we started typing.
And what's cool is you got to do it. And then, you know what? A mistake I've seen other teams make. I mean, I don't think it's as clear cut of like, what a risky decision making all of your own. But no, not at all. It's like, what if someone else owned it? How would you fix it and repair it? I mean, are you going to use a closed source backend server solution for your game? It's almost impossible to even imagine.
That's sort of the Pareto thing you get with middleware. Middleware gets you 80% of the way there, and you feel great, and you're just like, wow, this game's almost done. And then that last 20 is just everything that you realize that the middleware was not architected to do this thing that you want it to do.
This is one for the whole team. I mean, like, if you had a component you wanted to use on your game but it wasn't open source, would you even consider using it?
There's been a couple cases where we just had to do that. But
didn't feel that good. I mean, you want to look at it, you want to inspect it, make a change to it,
Like, I think our operating philosophy is, if we've never done it before, then we definitely have to build it, because we're not even qualified to evaluate whether or not the middleware is good.
That's a great attitude.
But there was a few cases where we're like, man, we built a bunch of those before and we just really don't have time. And this feels like it checks the box, and let's just do it. And I wish there was some middleware in a few places where it just didn't exist, and we had to write it, and it was, we were writing it again. I was like, oh man. Someone just make this. It'd be great. But
so another component that's really key to the success of your game. So free-to-play relaunch. Joe, do you want to talk about free-to-play and what's the deal? You released with EA, and you relaunched as free-to-play. I know I've talked to Guhar and Karthik. There's a lot of really interesting business decisions around that. But such a big transition of free-to-play, mid-cycle on the game, there's obvious business need for it. But I'm just thinking there's so many services required to support that. It must have been a really heavy lift for all of you folks.
Yeah, I mean, we started off. So we had an absolutely fantastic relationship with EA, and we were
great publisher, honestly, really,
yeah,
really good.
yeah. We were like, we knew from day one, we're like, okay, the game is going to be mid-price premium, $20-$30 or something like that, and after, like we'd been working on the game for quite a while, and after a while we were really in it, and we were like, you know what, it'd be really cool to make this game free to play. But there was enough in motion where, making that changing the business model mid-flight before ship just wasn't going to happen. So that's how we shipped the way we shipped. But it was certainly on everybody's minds while we were live, like how the launch had gone, how the community had received it, and when people say like, oh, the game should be free to play, and we're like, yeah, that'd be cool. And so now, like a year after launch, we're self-published now, so we did another difficult thing, which is we
add it to the pile.
Yeah, like we're like, hey, yeah, what if we took over self-publishing? And so a huge part of that was looking at a lot of the tech, the EA tech that we had in the game, and moving it over to Velan tech. So like all the commerce stuff that Jacob had integrated from EA, and that we had some of it was a challenge, and some of it was like we're super happy that we had it. Now it was like, okay, there's a mixture between Corey, Jacob, and Chuck now where we're going to re-implement these different things, and that's where like when we talk about cross-play,
that's a ton of work. Yeah,
when we talk about cross-play and cross-commerce and cross-progression, there's aspects to writing the back end where you're like, so pre-free to play, we were like, it's so much easier for this thing to just be cross-platform. Like if you're gonna tell me that all these, I have to partition all these users and stuff, it's like it's so much easier to just not do that. But then when you tell yourself, okay, well, we're gonna do commerce ourselves, and now you realize, oh, well, now I have to write, Chuck, like I have to write this what we call value transfer, which is going, receipt validation, going to the first parties and saying, hey, what did this user actually purchase, and what have I actually given them in game yet, and how do I consolidate that? And every platform is different, and so you have to
and you can't just route around this stuff. Like you must, for TRC, you must use that store, you must use that entitlement system, you just have to.
Absolutely. Because that's we're not at that point yet where we're actually taking credit cards off people and charging the money. So a lot of the transition to free to play was around that, was sort of like wrangling, like, okay, what stuff were we relying on our publisher for that we're gonna implement ourselves. But and aside from that, it's kind of been like, like we have our own relationship with the first parties now, and like, so our marketing department has grown, and we have like, a release coordinator now. So like we're the ones that decide, like we have to look each other straight in the face. So when we want to ship a build, and we're like, are we actually going to ship with this bug? Like, do we feel good about this? But it also affords us the ability to be able to do some other creative things that we couldn't have done with our prior relationship. And so like the turtles are in the game now, which is pretty awesome.
Yeah, I saw the Teenage Mutant Ninja Turtles. That's incredibly cool. Very cool. So one other thing we haven't talked about, upstate New York. I mean, a really big part of your studio identity is Troy, New York, up and coming. It's like Brooklyn used to be, is what everyone tells me. And as an Australian living in LA for 15 years, I actually moved over after meeting you guys. I want to live here. So I'm actually in upstate New York, just 15 minutes away. And cost of living is good here. You can get a house. You got Rensselaer Polytechnic. You got a lot of really good universities around here, and it's the beginning of a really interesting gaming cluster where Velan is a big part of that. How many folks you have at your studio now? I'd imagine it's
probably like 120, 130, something like that.
Holy, you were probably 30, 40 last time I chatted with you guys. Maybe
it's hard to.
It's incredible. Congratulations. Yeah. So if you want to move to upstate New York and work on some really cool games with these guys, we'll put up the careers page right now. The winters are cold, but that's okay. That's when we get the code.
That's a good thing. Thing. Seasons are great.
Seasons are awesome. And as an Australian who never grew up with seasons, honestly, snow's pretty cool. I like it. So check out the careers page. Everybody, thank you so much for your time today. I really appreciate it. And congratulations on the success of Knockout City. Your own engine, your own backend, free to play, self-published. The only question is, what's next? All right. We'll do another interview for that. Thanks, guys. See you later. Bye-bye.
Thanks.
Here's the hard truth. The internet doesn't care about your game. After all the blood, sweat and tears you put into making your game, you launch, and some players get terrible network performance. What can you do about it? Build your own internet? This is why we created Network Next. Network Next is a radically new way of linking networks together. It's a new internet. One where networks compete on a neutral marketplace to carry your game's traffic. Network Next puts you, the game developer, in control of the network. We monitor every player's network performance and you choose when to accelerate them. Not only will you see better network performance for your players, you'll also have the security of knowing that if one network is congested, we switch to another in seconds. Now you control the network.